I saw that Asheville, North Carolina. I'm
It's
from Boone. I'm from Boone, North Carolina, which is nowhere, but it's close to Asheville, North Carolina. So.
Nice. Okay, so I think we can get going. Welcome, everyone. So this is February the 3rd, and we are excited to have our next session in the Quant University Winter School 2021. So we've been having a series of lectures on the whole theme of adoption of AI and machine learning within the enterprise. And we have had a couple of interesting talks early this year on quantum machine learning. We have had talks on interpretability and explainability late in fall. And we have also looked at various themes on how do you responsibly adopt machine learning within the enterprise. And today, I'm glad to invite Patrick Hall from BNH.AI. And Patrick is no stranger to the whole responsible AI community. For many years, he has served as a spokesman of why explainability and interpretability is important for machine learning. And during his tour of duty at H2O, I had the pleasure of reading many of his writings on how AI and machine learning is important and some of the pioneering work they've done. In fact, some of the publications Patrick and many others at H2O wrote are still core reading materials in the whole area of pragmatic adoption of AI and machine learning within the enterprise. Obviously, there are a lot of theoretical frameworks out there and discussions on ethics and how we should be behaving as netizens and designers of software, and how we should be adopting various principles laid out from people from various research organizations and various other nonprofit and profit organizations. But I like when we kind of roll up our sleeves and see what's actually happening on the ground, and then address the core issues, which are really some things which, as engineers and data scientists and as machine learning professionals, need to work with, and especially in the financial services industry, wherein regulation and model validation and some of the core practices are some things which we have been working on for many, many years. We have the fiduciary responsibility as financial professionals to make sure that when we take responsibility of our clients' money and work with it, we have the right kinds of infrastructure. We do the due diligence to make sure that things are working. But we're also interested in making sure that some of the technology innovations which are kind of sweeping through the world, when we adopt them responsibly. And in that effort, as you all know, Quant University has been big into democratizing education, and we do a lot of work in the context of adoption of AI and machine learning within the enterprise. And we also do a lot of algorithmic auditing work with various entities to help them kind of bridge the gap between what does it mean to go from a traditional stochastic model wherein you're coming from Excel and MATLAB and Python models to potentially using TensorFlow and PyTorch and black box models wherein you're adopting various things. So I wanted to invite Patrick to today's session. So before we get going, I want to just share a couple of things on what's happening with the Quant University Winter School. As you all know, we have been hosting multiple sessions, and for people who are new to Quant University, we are based out of Boston, Massachusetts. We had 14 inches of snow yesterday. We love it in the winter. We love cleaning up the snow, and we go skiing, and we enjoy all the fun stuff. But we also do a lot of core research in various areas, and both from an academic and from a pragmatic perspective. And at Quant University, we've been leading various programs in the financial industry for a long time. What we have done is, in summer, we had the summer school, wherein we had a lot of speakers and a lot of different courses. And in the fall, we also invited many speakers. We had, in fact, more than 30 speakers from 13 different countries participate in our programs, and more than 2,500 people have attended various courses and lectures. So I'm so glad that you're all actively participating. And I hope some of the programming we are doing is adding value to your learning process and kind of contextualizing to various things you're doing. We also have many more programs coming up, so please do sign up at qwinterschool.splashthat.com so that you can get updated on various themes. And as mentioned today, we're going to be hearing from Patrick in a minute. And next week, we have Anupam from Truera. Anupam is also a professor at Carnegie Mellon University, and he's going to be speaking on AI and interpretability in machine learning. They've been doing some cool innovations at Truera, and also they've been trying to look at various ways in which you can kind of go under the hood and talk about things. So I'm very excited about this session. And for people who have missed out many of the sessions and would like to kind of catch up on things, we have all the recordings and the slides from our prior sessions available at qu.academy. Please go and check out some of those slides and videos. And if you have any feedback for us, or if you have any topics of interest, or you have speaker recommendations, please let us know, and we'll be able to see if we can invite them to our sessions. As I mentioned, at Quant University, give me 1 second. So we have, listed multiple events. So if you go to the quantuniversity.com and the events website, you see all the courses we are offering here in the winter school. And in addition to that, you have all the lectures which are going to be coming up in the next few weeks. So please join us, and I hope you have a wonderful session. So what I'm going to do now is hand over the stage to Patrick, and let him kind of talk about why should we care about failing machine learning models, and how do we kind of make sure that we also kind of protect ourselves and the models. So Patrick, I would also appreciate if you could tell a little bit about BNH and the work you do, and kind of why you chose to work in this particular area.
Sure.
So let me kind of make you the presenter, and if you can share slides, you can go ahead now. Thank you.
The title of this talk is What to Do When AI Fails, AI Incident Response. And I think for some people, this is just a complete no-brainer. Of course, AI is going to fail. And then for other people, it's, hey, wait, I've been told AI is this superhuman intelligence that can make decisions smarter and faster than humans. What do you mean it can fail? So I want to explore this subject and get into what we can do about it if and when an AI system does fail. We've been told that companies that wait to adopt AI may never catch up. That could very potentially be true. I'm not saying it is or it isn't, but this is a mindset that many, both data scientists and even going up to the executive level, people feel this pressure to adopt AI now, or you're going to get left behind by the competition. That hype leads to people not applying basic software standards and basic model governance standards, well known in both cases, to AI systems, right? AI systems are software. They're very specialized and sophisticated software. But for some reason, we oftentimes don't even apply the most basic software quality standards to them. So what happens in this situation where we're rushing to adopt a new technology? It shouldn't be a surprise. Okay, so I'm going to show a series of AI incidents. That's Microsoft's infamous Tay chatbot, who within about 16 hours on the internet experienced an attack, a security attack, a hack, and then later that attack turned into a discrimination problem. And that's one thing that's very interesting about machine learning. These problems, if you have an incident, it's not static, or it's not necessarily static. A security problem can morph into a discrimination problem. The next one is about a person who was kept in jail, denied parole, I believe, because of a black box machine learning output that was based on erroneous input. They had no logical recourse abilities. Here's the famous Goldman Sachs Apple Card debacle, which I'm not accusing anyone of a crime. That's still being investigated, but needless to say, it was a major PR headache for all the firms involved. And to be direct, these are some of the most well-resourced firms in the world, with armies of data scientists and attorneys who, if they can't get this right, then God help the rest of us. The self-driving Uber that killed someone. The healthcare algorithms that were modeling cost instead of need, leading to discriminatory outcomes in healthcare resource allocation. Companies, and you can look at this both ways. You can look at this, this suckers list thing. If you're a consumer, you might feel like the company is taking advantage of you. If you're the company, this might be a reputational harm, and you might dispute that this is true, but this information is still out there about you. Government AI, privacy problems, people being locked out of access to housing. Again, Microsoft, again, algorithms. Again, data privacy, self-harm, lawsuits, misinformation, physical security problems, blocking people at border crossings. And then, this final one, what these facial, and I teach at George Washington University, and people are using facial recognition systems that have not been proven out to decide if people are cheating on very serious licensing exams, like the California State licensing bar exam. I read that the deep learning flagged 33% of people for cheating, and they're going to try to investigate all of those. That's my understanding of the situation. That may not be current. Another thing I wanted to point out, the last 6 of these that I showed happened in the same week. Okay, at least the reports surfaced in the same week. So, and moreover, there's a database kept by Partnership on AI that contains 1,200 of these reports. Okay, so what I'm getting at is I don't really know how common this is, but it's certainly not uncommon. Okay, and we're going to talk about why that is and what isn't. So first we're going to talk about what is an AI incident. I've given you a bunch of examples on the screen, and then we're going to talk about what it is and then what you can do about it. All right, we like at my firm, we like to characterize AI incidents by 2 things. Materiality. Materiality is a word from traditional model governance that essentially means the cost of the harm multiplied by the likelihood of the harm. Okay, so if something is likely to go wrong, it has high materiality. If something is going to cost a lot when it goes wrong, it has high materiality. If it's both of those, it has very high materiality. You can offset that risk by being prepared for failure. And that will be a lot of the second half of this presentation is how do I prepare for failure and help mitigate the severity of an incident when it occurs. Okay, so we would say it's just easiest, and this definition is evolving, right? I think we were one of the first people to try to define this, and other people have since, and there could be a better definition by now. For us, it was easiest to say anything the model does that could cause harm is an incident. And then it's just, is it a bad incident or a minor incident that no one notices and doesn't really matter? Obviously, the ones I showed on the previous slide were very serious incidents that sort of spun out of control and affected people. All right. We also like to break AI incidents, and this is one reason why they're so complex. We're typically, if you have a background in model governance, and I saw some people on the attendee list that certainly have a background in model governance. I know Shri has a great background in model governance. In model governance, we're often concerned with failures. Humans made a mistake, and we're trying to catch that mistake before it gets out into public and does harm to consumers or to the organization. When we get into more complex AI systems, there's a legitimate security threat as well. So I not only have to worry about my own organization's failures leading to a problem when my machine learning system is deployed, I have to worry about adversarial actors out there in the world hacking my system. Okay. And again, I want to draw attention to that Tay incident. I think it's very, very prescient. Again, Tay was the female picture in the middle of the slide of all the AI incidents. Tay was a chatbot created by Microsoft Research. When they first put it on Twitter, it's just supposed to have happy, friendly conversations with people. She experienced what's known as I shouldn't say she, it experienced a data poisoning attack, which turned it into sort of a Nazi pornographer. Okay. So a security problem turned into a discrimination problem. And that's one reason why these AI incidents are so complex and deserve our attention. Okay. But I think it helps to try to think of them as, hey, is this a security problem? Has an adversarial or has an insider or sort of cyber adversary attack my model and cause it to fail? Or did essentially my team mess up and cause the failure? They can blend, and that's when things get very confusing. All right. Another issue with AI incidents is that it's just that incidents in complex systems are hard to prevent. Okay. So there's something known as the boreal cantellilimas that tell us about, like long tail black swan events. And essentially, and this notation is talking about an event. And what we're trying to say is, unless we can guarantee that either the probability of an incident for any interaction with my model, each interaction, the probability is 0 that there's an incident, or I can somehow guarantee that over time, the probability of an incident decreases despite things like data drift, which would naturally increase the likelihood of an incident. In case I can get myself into this very exceptional situation where every interaction with my model has 0 probability of an incident, or somehow I'm decreasing the probability of an incident over time, you're literally mathematically guaranteed to experience an incident. Okay. And this is not mind-blowing research that I did. It's straight out of a Google research paper. But a very insightful paper, I think. So keep in mind that incidents are common in complex systems, and that's well understood from aviation and nuclear engineering, right? And so it's just an inherent trait of complex systems that they can drift towards failure unless we put a ton of work in to keep that from happening. And again, that a lot of traditional modern governance, it does that. On that note, right, this is from the famous SR 11.7 paper. Model risk cannot be eliminated. All right, so we have Google researchers and fancy notation talking about previous research in aeronautics and nuclear engineering, incidents occur in complex systems. We have the Federal Reserve just telling us directly model risk cannot be eliminated. So other tools should be used to manage model risk effectively. Okay, and this is not going to be a surprise to many people on the line. For some of you, it might be kind of interesting to hear this. All right. All right. Now, why are AI incidents more common in machine learning, right? I think a lot of traditional model governance was set up for logistic regression models or maybe decision trees, simple rule-based systems. Those lessons are good lessons and many of them still apply. But when we move into the world of chatbots and robotic process automation systems, the number of things that can go wrong is just higher. And the scenarios, the different, because it's because of the context that the models are operating in. Okay. When we're just making yes or no sort of fraud decisions or credit decisions, that's an extraordinary limited context. And that is where machine learning does really well. When we open up the context to just a chatbot that can talk about anything, or a robotic process automation system that does several different tasks, we've expanded the context. And these bullet points that you're seeing on the left side, they essentially start causing a lot more trouble. All right. So when I'm in a very expansive context, when I have a system that's making decisions in a very expansive context, then these traits of machine learning that you're seeing on the left, they essentially become more troublesome. What are these traits? Well, you know, machine learning is based on statistics in almost all cases of deployed machine learning in the world today. Of course, there are types of machine learning that aren't as based on statistics, but generally speaking, we're basically doing statistical modeling, and so that means that we're going to be wrong sometimes. And again, people know how to manage systems that will be wrong sometimes. It's just less straightforward than having a black and white situation where being wrong is a bug. Okay, being wrong is a feature in machine learning systems, not a bug. Just makes testing harder. We can have these fantastically complex machine learning systems. I tend to think those aren't ever really necessary, but I could be wrong about that. Okay. Um, Complexity leads to higher probability of incidents. It's also hard to understand what's going on inside the models. And I really start taking exception when the engineers themselves don't understand significant parts of the model. Okay. I don't want to drive across a bridge where not even the engineers that made it understand each part of it. And I would claim that we are really in that space for very complex machine learning systems right now. Even the engineers that wrote the Python or C++ code, they don't fully understand what it's doing in some cases. And that makes it much harder to debug. Then we have this issue of decay, right? And if someone comes in and says, no, you can do online learning, I'm just going to send you back to the Tay chatbot. Okay. So typically machine learning systems are trained on static snapshots of data. The world drifts away from that static snapshot of data, and the machine learning system becomes less and less accurate over time. And if you think about your boreal cantellilimas, your probability of an incident gets higher and higher over time. And if you can't limit each interaction's probability to some very small number, that number is going to add up to 1 very quickly, and you're going to have an incident. I'm going to claim that the true incident response is a gap in model risk management. And I'll get into that a little bit more in a minute. On a close read of SR 11.7, they do say you should have contingency plans, but then that's kind of at the end of the paragraph, and they move on to the next subject. And that's pretty common in a lot of the implementing documents for regulation. So we can use incident response, this idea of just being ready for failure, to help us out here. All right, here's some analysis that allows me to make this claim that incident response is actually a gap in model governance today. So these are some domestic and international regulations. It's very common. So like in highly developed regulations like the Equal Credit Opportunity Act, it does make very specific, it has very, very specific recourse for what to do in certain situations, but not in other situations. And the same can be said for GDPR. So the GDPR lays out very detailed actions around data privacy harms, but doesn't really consider predictive modeling. And the UK's new version of the GDPR, does the same thing. I already said, the Singapore model AI governance and SR 11.7 sort of do the same thing. They say you should have contingency plans, but then move on. The recent FTC guidance doesn't bring it up at all. And then I would say that FINRA, which is a financial system regulator, and CFTC, which is a financial system regulator, they kind of do the same thing that SR 11.7 does, which is say, this is important, you should be prepared for things to fail, but then doesn't really move on, doesn't provide details. Crucially, it's also a gap in IT guidance, okay? So IT professionals like incident response is part of their education, and that's great. But AI incident response is not part of their education, okay? If you go, there's nothing in the SANS Institute or NIST incident handling guide that would help you find an algorithmic discrimination incident, okay? And that's a huge gap. I would say the most common kind of AI incident today is algorithmic discrimination. And these well-known industry guides that are excellent will not help you find that problem and will not help you respond to that problem. Okay. So it is a gap. It's not something that people are really taught about. And we kind of have to rethink how we deal with this risk. All right. And in fact, I think I'm not saying we should change model governance or anything like that, but I do think it's helpful to think about risk in terms of incidents. It can kind of take politics, ethics, these things that can be very difficult for large organizations to deal with. It can take those out of the mix. Okay. Um, so so we like to think about, things that you can do before the incident and things that you do after the incident. Um, and we like to think about enterprise-wide processes, such as model governments, such as AI principles. Those are mitigating processes that you can implement before an incident happens or after, but ideally before. Then we can get into specific sort of model assessment. So model audits or model validation for a specific system. And then, all kinds of incidents can happen. I don't think I have to beat that point, like a dead horse anymore. And once an incident happens, then you have to respond to it and recover from it. Generally speaking, this is more expensive than this. Okay, so keep that in mind. I think that's another thing that it's very difficult to make large organizations respond to arguments based on politics and ethics. It's much easier. It's a much more palatable argument to say extending your existing risk processes, insurance, incident response, risk mitigation, model risk management, expanding those to handle this wider array of AI incidents is cheaper and less embarrassing than responding to them when they happen. And I think that's a key argument in business that people are often missing. And I'm not excusing business from ethical concerns, anything like that. What I've experienced though is that companies are not yet ready mechanically. They have no mechanism to handle responsible AI. If we think about corporate social responsibility, corporate environmental responsibility, all those things were built up over years. And when people first started talking about them, organizations were probably very confused about what to do about them then too, right? And so we're just in that place with AI where we have to start introducing this notion in ways that companies can deal with now. So think again, insurance, risk management, model risk management, incident response. Those are things that companies know how to do now. If you try to make very political or ethical arguments, I think even if the company wants to move on them, it's very difficult. They just don't have any mechanisms. So I think it's nice. This is a nice way to frame risk. I'm not saying it's the only way, it's just a nice way. Okay. So when an incident happens, what do we do? All right. Well, unfortunately, usually when an AI incident happens, there's just a bunch of frantically asked questions. Okay. Is an incident, hey, someone is tweeting about our AI system, is an incident occurring? All right. If you can identify that an incident is occurring, then how do you even respond? If you don't have a plan, no one will even know what to do. Then you have to identify it and contain it. Do you have incident response teams? Who's going to handle the PR side? Who's going to handle the legal side? Who's going to call your insurance company? Who has the budget? Who's authorized? These are difficult questions that you don't want to be answering when your AI system shows up, in the newspaper or, on social media. And in particular, I want to go through some tabletop questions towards the end. So I don't want to linger too long on this slide. And I'll pause and also kind of address what's going on over here on the left in just a second. But what I'm trying to emphasize is you can imagine being in a situation where all of a sudden famous people on Twitter are saying your AI is discriminatory. It's being retweeted hundreds of thousands of times. News media is picking up on it. And everyone inside your organization is just yelling at each other, right? That's when the materiality starts increasing because you weren't prepared, right? What you're seeing on the left is, and I like to try to give some more examples of these real AI incidents. So I don't think the one on the left truly counts as a real AI incident, but a researcher was able to prove that like a $150 mask, he can trick payment systems and airport security systems. Okay. So there's just too much faith being put in these technologies and or not enough testing being done. I'm not exactly sure which one it is. All right. There are different incident response philosophies. This is a very traditional incident response philosophy: preparation, identification, containment, eradication, recovery, and lessons learned. All right. So if you're going to make an incident response plan, or you're going to have someone help you make an incident response plan, then this is how I would do that. This is how I would do that. Um, and there are other valid incident response taxonomies, but like I said, this is a fairly traditional one, where you want to be prepared. That means you have a plan. You've made an AI incident response plan. Um, and then you're able to identify incidents, you're able to contain them, eradicate them, and recover from them, and act on lessons that you've learned from the incident. And so this is how people handle hacking incidents. Okay, this is one way that successful companies handle hacking incidents. They're planning on it happening, they can identify it, they can contain it, they can eradicate it, and they can recover and learn from it. This is what we want people to be able to do from AI failures. What you're seeing on the other side of the slide in this case is the California, I believe this is the California State Bar exam again. This young woman reported that she had to shine an extremely bright light in her face the entire time she was taking her bar exam. Okay, so that the facial recognition system, and facial recognition systems are a big red flag for me. You know, they have very serious discrimination and privacy concerns that many times aren't mitigated. I'm not saying that you know, facial recognition should be banned. I'm saying it should be used much more carefully than it's being used today, or else you end up in situations like this where you have this young woman who has to shine an incredibly bright light in her face the whole time she's taking her bar exam. Okay, so do you think that's going to help her succeed on the bar exam? And it's just, and this is happening to an entire class of people. It's tragic. And then it ends up in the media. Okay, and I would consider the fact that it happened and that it ended up in the media both different kinds of AI incidents. Okay. How do you stop these things? And I'm going to show a full-on sample incident response plan, before the end here. But you know, I think that one reason we want transparency into models is to prevent incidents. Okay, maximum transparency enables maximum debugging. I'm not saying you can't govern black boxes. I'm not saying that, you know, black boxes are completely evil or something like that. But what I am arguing is that the more transparent a model is, the more debuggable it is. And the more debuggable it is, the more governable it is. So aside from just basic transparency into machine learning, which sounds like Shri is going to have a lot of great speakers on that, and I know the one coming next week is great. You know, there are other sort of process things that you can do that are going to look extremely familiar to model risk management professionals. Just keep an inventory of your AI systems. You know, if you don't know how many AI systems or machine learning systems your company is using, that's a big red flag. If you don't know who's in charge of them, big red flag. The next step is to monitor them in real time. Okay, so if you have an AI system, can you even know that it's failing or potentially being attacked? Can you know that it's committing, you know, being discriminatory? So you have to monitor these systems, which is a big engineering effort. And I've seen this create, this can create internal friction because at companies that don't have structured model governance, because whose job is model monitoring? It's an incredible burden for the data scientists because it's more of a traditional engineering task to build the model monitoring systems, but then, you know, the data scientists are needed to chime in on whether the models are behaving correctly. So model monitoring is both a technical and a process challenge, but people are getting much better at it. There's other processes that you can do that we could borrow from traditional IT security. There could be bug bounties, right? You can pay people to find problems in your AI systems before they spiral out of control. You can do what's known as red teaming, where you pay a third party or you have a specific internal team that essentially tries to break and hack and make your machine learning look bad? Can they do that? These are very common practices from an IT security perspective that people just don't do on AI because AI is special, supposedly. Um, Documentation is hugely important. Again, a cornerstone of traditional model management. Um, and I think the question you want to ask with model documentation, right? There are very thorough standards that you can look at, but I think two basic questions I would want to ask if I had a document that described a machine learning system would be, one, can someone new join my team, read this document and understand what to do with the model? And two, if something goes wrong with my system, does this document help me, right? I'd want to hear a yes to both of those for good model documentation. Um, don't wait until it's too late. The AI incident response plan. Let's go ahead and show that real quick. All right, so this is our little GitHub. I think we may be one of the few law firms in the world that have a GitHub page, and we're proud of that. So you can see here we've put some information out about how to get started planning for AI incident response. And then some information about, how do I identify what kind of incident is occurring or if an incident is occurring. Okay, so this resource we've made publicly available. It's fairly academic. There's a reason that we're not charging for it, which is that it's very, very general and it covers almost every possible angle. And it could be a little unwieldy to work with, but I certainly think it could be helpful for designing your own system if you keep in mind that what we've put out for free is very general and very thorough because we're trying to address any possible incident. I think you could cut yourself, you could make your work a lot easier if you were targeting your own company and your own domain. And of course, this is a service we offer. I'll get to that later. This is not meant to be a commercial. Let's see, how do I make this go away? There we go. Okay. So that's what I mean when I say an AI incident response plan. Being prepared for an incident. You need a written plan that people have rehearsed, okay, through a tabletop. If not more, serious drills. So then I would love it if people would participate in these sort of nascent AI security efforts. So there is this AI incident database that volunteers like me scour the internet and find incidents and report them to the database. You could think about having your organization either have access to this database so that you could review incidents and not repeat them. Okay, that's a really key point about storing these incidents in a database. The reason we do that is not to make companies look bad. It is to build a database of incidents so that we don't repeat past mistakes. Okay, and that is a practice that is just straight up stolen from aerospace and nuclear. Okay. You record and investigate incidents so that you learn from them and you don't do them again. You don't just watch your competitor make a discriminatory algorithm and then you go make a discriminatory algorithm, even though that is what's happening today. So I think we're still in the phase of machine learning where, when we think back to like when airplanes crashed into mountains a lot, okay, that's kind of where we are with machine learning. Machine learning is making the same mistakes over and over and over again because people haven't even gotten to the point yet where we're studying our mistakes and learning from them. At least generally speaking, I'm sure some of you do that. But keep that in mind. Like we're really in early days, even though machine learning is old and dates back to the 1940s or 1950s. We're still in early days of this technology. The incident that you're seeing on the right of this slide this time is just an example of sexism in term embedding models, which is very, very prominent because term embedding models are trained off racist text from all over the internet. And Google Translate can't translate things like historian and doctor in very common languages. It can't translate that into the female form. And to me, that's just shocking. Well, I don't know if it's shocking. It's shocking, but not surprising, I guess is the right way to say that. And this group Algorithm Watch is interesting in terms of some of the research they put out. Okay, so now I want to try some tabletop questions, but we'll just turn this over and into kind of being a discussion. I want to just show, and Shri has these slides, but I want to make sure, here's the sample AI incident response list. That's the link to that. That's, the rest of these are sort of shorter, shorter pieces on incident response or risk that you can read about. And you may, if you know, you're just getting into this idea of machine learning risk, you may find this this piece that we did with Partnership on AI helpful. It's just 10 very basic questions about AI risk that's meant to be potentially answerable, like at the C level or maybe even the board level, because they're based off questions that senators sent in letters to executives of health insurance companies. Okay. All right, getting back to my slides. And just, I want to emphasize, you know, Andrew, my partner, and I at BNH.AI, he's the real attorney. We do offer services around this methodology, and we would be happy to hear from you on that. I'm going to go back to these tabletop questions, and you know, we can go over these, or we can just save the last 10 minutes for kind of an open discussion.
Yeah, I think you know, the question answers. I think I'll be. Can we share these slides to the with the audience?
Yeah, please.
Okay, so let's do that. I mean, okay. We'll save the last 10 minutes for Q&A.
Yeah.
This was like a fascinating discussion. You know, many of the themes which you know, are near and dear to me, kind of covered it. So people in the audience, please feel free to use the chat window or the Q&A window to ask any questions you may have. I know there was one question. It's probably a generic question. How far are we from Minority Report type of society?
I'm genuinely worried about that. Okay, I don't think it's likely, because there's a lot of people who are on top of this and studying this. I'm kind of interested to switch back to Zoom. There's a lot of people that are on top of this and studying this. But I sincerely believe that without sort of strong federal regulation, which is already happening in the EU, you know, at the EU level, we could get into a very bad future of surveillance state and disenfranchisement. And I was actually, I'll try not to be too long-winded and not run my mouth too much, but just think about it. Okay, right now in this country, in the United States, there's an entire group of people that has limited internet access. Okay. Oftentimes these same people are having predictive policing systems send more police to their neighborhoods. They are, when they interact with the police, they're more likely to be arrested. They're having potentially biased, I'm not saying.
I think we lost the audio for a bit, Patrick.
When getting credit, which, you know, makes it harder to get more internet access, makes it harder to get, you know, better legal outcomes. So I would actually turn this question around a little bit and say, you know, some people could be potentially experiencing like a very different interaction with digital society than the people who are dialed into this call, most likely, right? And I said the same thing to my students this morning at George Washington, right? It's not, I'm not saying any of us are special and we haven't had hardships. It's just like, if we're able to dial into this call and understand what's going on, then like we're living in a very different digital world than some other people in this country. So maybe this is already happening to a certain degree.
I actually was kind of, you know, when you were talking about the potential problems which AI is going to bring into society and for various companies, right? So there are like two aspects which I kind of typically look at it. One is the knowledge gap, right? So wherein you have increasing sophistication in models, you have complexity increasing rapidly, and you require a PhD in a very specific discipline to really understand what it actually does. And there's no way you can build in that level of expertise at every institution. I was kind of talking to someone like, what do the 50 to 100 million banks do? Are they going to be hiring like teams of data scientists with PhDs trying to like build algorithms, or are they going to be using algorithms as a service? How do you kind of, handle the complexity issue wherein you don't know what you're using, but the example you gave, like, about the bridge being built by people who don't know what they're doing versus a toaster, which I really don't understand how I'm actually using it, but I know that it's been rated by someone, it has gone through certain due diligence, and I'm comfortable picking up a $20 toaster and using it without the fear of being electrocuted. So that's like one part of the aspect, right? And the other aspect is the malicious intent, wherein some of the examples you were kind of talking about, wherein potentially you could use AI to control access to certain resources. Potentially you could make certain things, kind of discriminatory by design. So that, you were kind of, there was in the Boston area, there was something in the Boston Globe today about, access to vaccines, and they were kind of, talking about, well, people who knew how to get into the right systems, people who can like log in, people who can, enroll. There's no AI in there, just access to system and knowing where to go. And it's kind of ironic because right now we are targeting 75 and above, and those are like the segment of population who are less tech savvy. They need other people to help them out with like just going and logging in and doing things. And there are other people who are, potentially helping them, but we're kind of creating systems wherein the end user is not in mind, right? How do you kind of look at both aspects? Like, one is the you need to like delegate the responsibility of vetting out these algorithms to maybe an algorithmic auditing agency or an agency like yours to look at various spectrums. But then also we need to watch out for the malicious aspects of it, wherein we need people to like, shout out saying, hey, this is not cool. We shouldn't be doing this, so that no one else actually does that.
Yeah, these are all very tough questions. I think that what I'll talk about is sort of an answer to both of them, is context. Okay, and I hinted at this earlier. When we have credit models that's just, and it's more, obviously it's more complex than this, but essentially making yes or no binary decisions about credit. We have fraud models making yes or no binary decisions about, to accept a transaction or, flag a financial transaction. That is a very limited context. Okay, and that is where machine learning succeeds. When we expand the context, into this broad socio-technical, sorry, I'm going to say context again. When we're in this broad socio-technical context, it's very hard to even imagine what can go wrong, right? There's a really good paper about it was a NeurIPS workshop paper this year called something about failure of imagination. And it was a meta-analysis of the researchers' own impact statements, right? And you may be aware that in NeurIPS this year, they had to do an impact statement, right. And that was extraordinarily controversial. And, people resigned from Twitter or got off Twitter, and there were enemy lists and all kinds of stuff going on.
Track the whole phenomenon.
Yeah. And so just an analysis of that, and what they said was there's a failure of imagination, right? And that's not surprising. Engineers think about Python and GPU and C++. They don't think about like, hey, when I deploy this into the real world, what are all the wild things that could happen, right? And I don't know if that's the engineer's job or not. They certainly bear some responsibility, say up to the level of a physician or a civil engineer, right? We expect them to be able to think through their actions. But they don't need to do, it's not their job to solve all these problems, right? So these are very complex problems that are going to take teams of people to answer. And again, that's why I chose to go work with an attorney, because I just think that it's going to take combinations of expertise to answer these questions, and I don't think we know what the answers are yet.
Absolutely, and it's a fascinating area. And I was kind of discussing with a colleague of mine, and we were looking at, from the opportunity space, there's so many cool things happening, but also when it comes down to adoption, we're asking the right questions. We're asking the questions which material which are required, and especially in a financial industry context wherein we are not always on the cutting edge to try and like get the latest technology from GitHub and like deploy it in our algorithms tomorrow.
Probably a good idea.
But again, you got to do your due diligence, right?
Yeah,
So, and again, these discussions are extremely important. So I'm so glad that you were able to make the time despite your busy schedule. And I know the life of an adjunct professor. I am one, so I teach Friday evenings and Saturday afternoons. So my weekend starts like Saturday 6 o'clock when all my emails to my students are done and they're kind of good to go. But I'm so glad that you're kind of sharing your expertise and your thoughts on all the important things with the world. And I'll be sharing your slides and the link to the GitHubs you posted with our audience. And really appreciate you taking the time to come to the Quant University Winter School 2021. And I'm looking forward to seeing how this whole effort progresses and how we can potentially partner and kind of bring up more discussion and more pragmatic frameworks and usable tools to the industry, so that we can address the problems and also look for opportunities to make this process more rigorous and practical.
Yeah, well, and we're done, but I'll just say I think incident response is just one of the simplest answers, right? Just be prepared for the thing you're working on to fail, because that's what we did with airplanes and nuclear reactors and other powerful commercial technology. But great to be here, and I do have to run, but thank you everybody who dialed in today, and please be in touch. LinkedIn, Twitter, I'm fairly easy to find, and thank you, Sri, for having me.
Absolutely. Yeah. Thank you so much. I appreciate it.
Take care.
Okay. So next week we have Anupam Datta from Truera, who's going to be speaking. And if you are interested in joining our mailing list or attend any of our future sessions, please go to www.quantuniversity.com, and we have all the courses. We are also offering a bunch of courses later in the year, so please check them out. And if you have any questions or feedback for us, please do let us know. So looking forward to talking to you again in another week, and I hope you have a warm winter for the rest of the week, and see you soon. Take care. Bye-bye.